Our world is a dynamic tapestry of life, woven from countless species interacting within diverse ecosystems. Yet within this intricate web, there exists a hidden threat that can emerge suddenly and spread rapidly: infectious diseases. Today, we delve into the fascinating and sometimes frightening world of emerging infectious diseases, exploring the factors that contribute to their emergence and spread, including zoonotic pathogens, antimicrobial resistance, and pandemic preparedness. Throughout history, humanity has faced numerous outbreaks, from the bubonic plague in the Middle Ages to the influenza pandemic of 1918. But in our interconnected modern world, the threat of emerging infectious diseases has never been more pronounced. Many emerging infectious diseases originate from animals, known as zoonotic pathogens. These are viruses, bacteria, or parasites that jump from animals to humans, often with devastating consequences. The process, known as spillover, occurs when humans come into close contact with wildlife, whether through hunting, habitat encroachment, or markets that sell live animals. Wet markets, where diverse species are kept in close proximity, provide a perfect environment for zoonotic pathogens to leap from animals to humans. For example, the Ebola virus, which has caused several deadly outbreaks in Africa, is believed to have originated from fruit bats. When humans hunt or consume infected animals, the virus can cross over and initiate a human outbreak. Human activities such as deforestation and urbanization increase the likelihood of spillover events by disrupting natural habitats and bringing wildlife closer to human populations. Once a zoonotic pathogen makes the leap to humans, it can spread through various means: direct contact, contaminated food or water, and even through vectors like mosquitoes and ticks. Mosquitoes, for instance, are notorious vectors of diseases such as malaria, dengue fever, and Zika virus. These tiny insects are responsible for transmitting pathogens that cause millions of illnesses and deaths each year. Another critical factor in the emergence of infectious diseases is antimicrobial resistance. This occurs when bacteria, viruses, fungi, and parasites evolve to resist the drugs designed to kill them. Overuse and misuse of antibiotics in humans and livestock accelerate this process, allowing resistant strains to flourish and spread. As a result, common infections that were once easily treatable are becoming more difficult to manage, posing a significant threat to public health. The rise of antimicrobial resistance has global implications, as resistant pathogens can travel across borders with ease, facilitated by international travel and trade. In our globally connected world, infectious diseases can spread rapidly across continents, turning local outbreaks into global pandemics. The COVID-19 pandemic, caused by the SARS-CoV-2 virus, illustrated how quickly a novel pathogen can traverse the globe, disrupting lives and economies on an unprecedented scale. Pandemic preparedness involves a range of strategies, including surveillance, rapid response, vaccine development, and public health measures. The development and distribution of vaccines are critical components of our defense against emerging infectious diseases. Advances in technology have enabled the rapid creation of vaccines, as seen with the COVID-19 vaccines developed in record time. Addressing the threat of emerging infectious diseases requires a holistic approach known as One Health. This concept recognizes the interconnectedness of human, animal, and environmental health. By understanding and addressing the links between these domains, we can better predict, prevent, and respond to disease outbreaks. Collaboration between veterinarians, ecologists, and public health professionals is essential for early detection and response to potential zoonotic threats. Let us explore some case studies of emerging infectious diseases to understand their impact and the lessons learned. HIV, the virus that causes AIDS, is believed to have originated from primates in Central Africa. The virus crossed over to humans through hunting and consumption of bushmeat, leading to a global pandemic that has claimed millions of lives. The Ebola virus, with its high mortality rate, caused devastating outbreaks in West Africa. The international response involved intense medical intervention and community engagement to control the spread. The Zika virus, transmitted by Aedes mosquitoes, emerged as a significant threat, particularly to pregnant women, due to its association with birth defects. Efforts to control the mosquito population and public awareness campaigns were crucial in managing the outbreak. Emerging technologies offer new tools in the fight against infectious diseases. Genetic engineering techniques, such as CRISPR, allow scientists to edit the genomes of pathogens, potentially rendering them harmless. CRISPR technology, for instance, enables precise alterations to the DNA of viruses and bacteria, paving the way for innovative treatments and vaccines. Drones equipped with surveillance capabilities are used to monitor disease outbreaks in remote and inaccessible regions, providing valuable data for early intervention. Artificial intelligence, AI, analyzes vast amounts of data to predict disease outbreaks and optimize response strategies, enhancing our ability to stay ahead of potential pandemics. While governments and scientists play crucial roles in managing infectious diseases, individual actions are equally important. Simple practices such as good hygiene, vaccination, and responsible use of antibiotics can significantly reduce the spread of diseases. Vaccination not only protects individuals, but also contributes to herd immunity, reducing the overall prevalence of disease in the community. Public awareness and education are vital in promoting healthy behaviors and ensuring that communities are well prepared to face emerging infectious threats. The fight against emerging infectious diseases is a global endeavor. Organizations such as the World Health Organization, WHO, and the Centers for Disease Control and Prevention, CDC, work tirelessly to monitor, prevent, and respond to disease outbreaks. Global cooperation involves sharing information, resources, and expertise to mount effective responses to emerging threats. International health regulations and agreements facilitate this collaboration, ensuring that countries work together to safeguard public health. Looking ahead, the future of infectious disease management will be shaped by continued advancements in science and technology. Personalized medicine, leveraging genetic information, promises tailored treatments and vaccines for individuals, enhancing efficacy and reducing side effects. Precision medicine targets specific pathogens within the body, offering more effective treatments while minimizing harm to healthy cells. Global health summits bring together leaders, scientists, and policymakers to discuss and implement strategies for preventing and managing emerging infectious diseases, fostering a collaborative approach to global health security. Emerging infectious diseases pose significant challenges, but they also drive innovation and collaboration. By understanding the factors that contribute to their emergence and spread, and by leveraging science, technology, and global cooperation, we can build a safer and healthier future for all. Climate change, a formidable force altering our planet's ecosystems, is also playing a significant role in the emergence of infectious diseases. As temperatures rise and habitats shift, animals migrate to new areas, bringing their pathogens with them. This increases the likelihood of zoonotic diseases spilling over into human populations. Changing weather patterns, such as increased rainfall and flooding, create ideal breeding grounds for vectors like mosquitoes. This can lead to the spread of diseases such as malaria, dengue fever, and West Nile virus into regions where they were previously uncommon. Similarly, warmer temperatures allow ticks, which transmit diseases like Lyme disease, to expand their range, exposing new populations to these illnesses. Biodiversity, the variety of life on Earth, plays a crucial role in regulating the spread of infectious diseases. Healthy ecosystems with rich biodiversity can act as buffers, reducing the transmission of pathogens. In diverse ecosystems, many species can interrupt the transmission chains of pathogens, reducing the likelihood of a disease spreading widely. However, when biodiversity is lost due to activities like deforestation and habitat destruction, these natural buffers are weakened. Monocultures, large areas planted with a single crop, lack the diversity to control pest populations and can become hotspots for the spread of plant and animal diseases, some of which can spill over to humans. In today's interconnected world, global travel and trade can facilitate the rapid spread of infectious diseases across continents. Air travel can transport infected individuals from one side of the globe to the other in a matter of hours, allowing diseases to spread far and wide before they are detected. Similarly, global trade can inadvertently transport disease vectors, such as mosquitoes and rodents, in cargo shipments, introducing them to new environments where they can establish and spread. The outbreaks of SARS, MERS, and COVID-19 illustrate how quickly and efficiently respiratory viruses can spread through international travel, underscoring the importance of global surveillance and response mechanisms. Thank you for joining us on this journey into the world of emerging infectious diseases. Remember, each of us has a role to play in protecting our health and the health of our communities.